So let's look at this problem. Give an example of a relation which is symmetric but neither reflexive nor transitive. So we need to find an example where it should be symmetric but not reflexive and not transitive. So we know what is the condition for symmetric. So reverse combination should be there. If you have 1, 2, you should have 2, 1. So simply put a set, call it as R, and take the set as set A. Let set A be 1, 2, 3 and let the relation be 1, 2 and 2, 1. Now this is symmetric because the reverse combination is there, right? 1, 2 and 2, 1. Reverse combination is there. That's why it is symmetric. Now it should not be reflexive and it should not be transitive. So it is not reflexive because for every element of this set, we have 1, 2, 3. We should have 1, 1, 2, 2 and 3, 3. None of these are there, right? Therefore, it's not reflexive. Transitive. It is not transitive because if 1, 2 and 2, 1 is there, then you should have first and fourth element. That is 1, 1, right? You should have 1, 1. So 1, 1 is not there. So we're telling R is not transitive as 1, 2 belongs to R, 2, 1 also belongs to R, but it does not imply that 1, 1 belongs to R, right? 1, 1, this element and this element does not belong to R. Hence it's not transitive. You can write it as does not imply, or you can say but 1, 1 does not belong to R, right? You can say it like this also. You can say it does not imply that 1, 1 belongs to R, or you can say but 1, 1 does not belong to R. The next one, we will have to give a relation which is transitive but not reflexive and not symmetric. Now, first one, it should not be symmetric means the reverse combination should not be there. So you have 1, 2 but you will not have 2, 1. You have 1, 3 but 3, 1 is not there. So the reverse combination is not there. So we'll say R is not symmetric as 1, 2 belongs to R but 2, 1 does not belong to R. Right? So you take the same example, same set, right? And just modify the example. The same example that we took here, just modify it, right? So that you don't have reverse combination. So now we prove that it is not symmetric. We'll also have to say that it is not reflexive. For reflexive, you should have repeated elements in the ordered pair like 1, 1, 2, 2, 3, 3. None of these are there. So therefore, it is not reflexive. R is not reflexive as 1, 1 does not belong to R, 2, 2 does not belong to R, and 3, 3 does not belong to R. Now it should be transitive. It is transitive. So if you take 1, 2 and 2, 3, that means the first and fourth element should be there. First and fourth element should be there. That is 1, 3. So 1, 3 is there. So therefore you say it is transitive. Now here we have to give an example of a relation which is reflexive, which is symmetric but not transitive. It should be reflexive means there should be repeated combinations. So we have taken this set, right? We have taken set of elements which has 1, 2 and 3. So for reflexive, you should have 1, 1, 2, 2, 3, 3. So this will indicate that the relation is reflexive. So we'll say R is reflexive as 1, 1, 2, 2, 3, 3 belongs to R. That is, for every element A belonging to A belongs to R. Now, we'll see if this particular example is symmetric, right? If you have to prove that it is symmetric, you will have to take the reverse combination. If you have taken 1, 2, you should have 2, 1. If you have taken 2, 3, you should have 3, 2. So, it is symmetric, right? You should have all the reverse combinations. 1, 2 has 2, 1, 2, 3 has 3, 2, but this should not be transitive, right? Which means if I take 1, 2 and 2, 3, here the second elements are same, right? Second elements are same. So for transitive, you should have first and fourth element, right? So 1, 3. 1 comma 3 is not there, right? Therefore R is not transitive. So we should say R is not transitive as 1 2 belongs to R, 2 3 belongs to R, does not imply that 1 comma 3 belongs to R. Now let's look at the next one. Here we have to give an example of a relation where relation is reflexive and transitive but not symmetric. The relation should be reflexive. So straightforward. If it has to be reflexive, we have taken the same set A is equal to 1, 2, 3. So for it to be reflexive, you should have ordered pairs with same elements like 1 comma 1, 2 comma 2, 3 comma 3. Right? So this satisfies the reflexive condition. So R is reflexive as, so for every element that belongs to A comma A should belong to R, which is 1 comma 1, 2 comma 2, 3 comma 3 belongs to R. Therefore, this is reflexive. Now, we'll have to ensure that this particular example is transitive also. Now, and for reflexive, it's easy, right? So, same element should be there. For transitive, you'll have to pick two ordered pairs in such a way that we get the third ordered pair. Now, if you look at, we'll have to take ordered pairs where second element is same, right? Second element should be same. Now, if I take 1 comma 2 and 2 comma 2, right? I can take 1 comma 2 and 2 comma 2. So here, if you notice, second element is same. So that's how we have to choose the ordered pairs. So what will be the third pair for this? Third pair will be first and fourth elements, which is 1 comma 2. So here transitive is satisfied. This case, transitive is satisfied. Now you'll have to look for all the possible ordered pairs here and everything should be transitive. Now again we'll see if there are any common elements. So if you here between 1 and 3 and 3 and 3, between 1 and 3 and 3 and 3 also second element is common, right? Now, so what will be the third ordered pair? It will be 1 comma 3. So here this one. So this condition is also satisfied. This ordered pair also is transitive. Then we'll have to look for all such combinations. So now with 1 also you can see, right? With 1 also there is a common element with 1. So with 1 you have 1 comma 1 and 1 comma 2. 1 comma 1 and 1 comma 2. So the second element is same. So what will be the ordered pair? Third ordered pair, first and fourth element. So it's 1 comma 2. So this condition, this one, this is also satisfied. Now there is another combination with 1 comma 1 and 1 comma 3. With 1 comma 1 and 1 comma 3. Right? With 1 comma 1 and 1 comma 3, you have the second element as 1, which is same. So the fourth ordered pair should be 1 comma 3. 1 comma 3. 1 comma 3 is here. So like this you have 4 combinations here. You will have to look for every combination and you will have to check for transitive. So all the 4 combinations are satisfying here. You have to check for all ordered pairs and then see if it is transitive or not. So now in this example you got 4 cases. So it's better to take where you have lesser combinations. So maybe what we should do is we should remove 1 comma 3. Right? 1 comma 3 is not required here. Without that also you can prove that it is reflexive and transitive. Now for example, let me take this relation, right? In this case you will see lesser number of combinations. So here this 1 comma 3, these two combinations will get eliminated, right? Because we have removed 1 comma 3, these two combinations will get eliminated. You will only get 2 cases, which is easier. So with this set also we can prove that it is reflexive and transitive. Let's check if it is not symmetric. Obviously it will not be symmetric because you don't have the reverse combination. What is the reverse combination? 1 2 2 1. 2 1 is not there. So we'll say R is not symmetric as 1 comma 2 belongs to R does not imply that 2 1 belongs to R, right? You can write it like this or say 1 comma 2 belongs to R but 2 comma 1 does not belong to R, right? You can see it like this or you can say it in this particular method. Does not imply, right? 1 comma 2 belongs to R does not imply that 2 comma 1 belongs to R. Now let's take this fifth one. You'll have to take an example which says that it is symmetric and transitive but not reflexive. Symmetric, straightforward, right? Take the reverse combination. So 1 comma 2, 2 comma 1. So this will satisfy symmetric. And transitive, you should have 3 ordered pairs if you have to prove it's transitive, right? Minimum 3 ordered pairs should be there. Minimum 3 ordered pairs for you to prove that it is transitive. Here you look at the common elements. You have 2 and 2 common. So you have to take first and fourth. You have to take first and fourth as the third ordered pair. So it should be 1, 1. 1, 1 is there. Therefore, this relation is transitive. Do you see any other ordered pair which has common element? The second element and the first element should be common like this, 2 and 2. This is the only combination where 2 is common. Therefore, this is transitive. So you say R is transitive as 1, 2 belongs to R and 2, 1 also belongs to R, implies that 1, 1 belongs to R. Now it should not be reflexive. Reflexive simple condition is you should not have the repeated elements, right? So you have 1, 1 here, but you don't have 2, 2 and 3, 3. So R is not reflexive because for every element belonging to set A does not belong to R. That is 2, 2, 3, 3 does not belong to R. Therefore, R is not reflexive. So, if you found this video useful, do press a like and share it. Thank you.